So in the previous video we had discussed about the algebraic system and its properties. Okay, so let A be a non-empty set with addition and multiplication as two binary operations. So which are the properties of algebraic system? Closure property, then associative property, commutative property, existence of identity, then existence of inverse element. In addition, inverse of A is minus A, and for multiplication, inverse of A is A inverse or 1 by A. A inverse is same as 1 by A. Okay. And distributive properties there, left cancellation law, then right cancellation. So these are the properties of algebraic system. And what is an example of algebraic system? Set of integers under addition and multiplication. Multiplication also it is algebraic system. Then our set of real numbers under addition and multiplication. Okay. So next one is homomorphism and isomorphism. Let x under multiplication and y under star be any two algebraic system. That means x is a set with the binary operation as dot multiplication, and y is another set with a binary operation as star. So these are the two algebraic system. Then we have to define a function f from x to y. It is called a homomorphism. It is when it is called an homomorphism if you consider any two elements from the set x, x1, x2 belong to x, and you apply the function f of x1 dot x2, because in x what is the operation? Dot is the operation. So we have to apply the dot x1 dot x2. And what is the answer? What is the output? We have to obtain f of x1. What is the image of x1 in y? So what is the operation in y? Star. So f of x1 star f of x2. F of x1 and f of x2 are any two elements in y, and that elements are to be operated using the operation star. Okay, so f of x1 dot x2 is equal to f of x1 star f of x2. And in some cases these two operations can be same. For example, in the case of addition, if it is a plus here also we can put plus. Okay, so that is known as homomorphism. And in that homomorphism, if f is the function is 1, 1 and on 2, then f is called an isomorphism. Okay. So what is known as homomorphism? Two sets are there, x and y. Here the operation is dot, here the operation is star. So we have to consider a function f from x to y. So this is x, this is y. So x to y there is a function. So here the elements are x1, x2, etc. Here also there are elements y1, y2, etc. But this y is known as the image of x. So f of x1, y1 can be named as f of x1, y2 f of x2. Okay. So so here in x, which are the elements? x1, x2. So suppose x1, x2 belong to capital X, and you apply f of, we have to operate these two x1 and x2 using the, what is the operation in x? It is star. So dot. So f of x1 dot x2 will be f of x1 star f of x2. Okay, f of x1 star f of x2. F of x1 is the image of x1 in y, and f of x2 is another image of x2, that is known as y2. Okay, so these two elements belong to where? F of x1 belong to y, f of x2 also belong to y, because image of x1 under the function f belong to y. Okay, so in y what is the operation? It is star. So we have to apply star between these elements. So f of x1 dot x2 is equal to f of x1 star f of x2. Suppose in x also star is there, y also star is there, then what will be that? F of x1 star x2, because in x the operation is star, it will be f of x1 star f of x2. because in y also the operation is star itself. Okay, so in this case these two operations will be same. F of x1 star x2 is equal to f of x1 star f of x2. So if it satisfies, what we call this star as, we can call that this is an homomorphism. Okay, the function f is said to be an homomorphism. F is said to be a homomorphism. Okay, and if the function f is a homomorphism which is 1 1 and onto 1 1 and onto, so the function is homomorphism 1 and onto. If these three properties are satisfied, then it is said to be isomorphism. Okay, if the function f is homomorphism 1 1 and onto, so which are the conditions it should satisfy? If it is homomorphism, f of x1 star x2 is equal to f of x1 star f of x2. Okay, this is like a distributive law. Okay, f goes to inside the bracket. Okay, then that is the condition for homomorphism. 1 1 means f of x1 is equal to f of x2. What is the condition for 1 1? F of x1 is equal to f of x2 implies x1 is equal to x2. 1 1 means if the images are same, then the pre-images are also same. So that is the condition for 1 1. Okay, next, what is the condition onto? When we say that the function is onto, suppose f is a function from x to y, so we can take an x from x and y from y. Okay, so for every y in y, for every, you have to consider all the y belong to the y. Their x is a some x, their x is some x in x. Okay, for every y in y, we have to get an x in x such that f of x is equal to y. Okay, so for every, we have to consider all the y in y, then we have to get a x in x such that, what is that x? It is f of x is equal to y. It is such that f of x is equal to y, that is image of x under f is equal to this y. Okay, so if this condition satisfied, it is known as onto function. So what is meant by isomorphism? A function f from x to y is called isomorphism if it is homomorphism 1 1 and onto. Okay, so it is 1 1 onto homomorphism. We can say that, yeah, an isomorphism is 1 1 onto homomorphism. Okay, so that is the condition for isomorphism.